Okay, this is an example problem from section 11.2 where we're doing a permutation with repeated items. And the formula for repeated items is the permutation is equal to n factorial over p factorial times q factorial times r factorial, where n is the total number of items and p is the repeated items of the first item, Q is how many are repeated in the second, R is how many are repeated in the third, and so on. So the question is, how many ways can we arrange the numbers in 9,444,333? So there's 1, 2, 3, 4, 5, 6, 7 digits, so n is 7. There's actually 1, 2, 3 different digits all together, because we have repetition. So P would be 1 because there's 1 9, Q is 3 because there are 3 4s, R is 3 because there are 3 3s, and if we had more repeated numbers, we would just keep going. So that becomes 7 factorial over 1 factorial times 3 factorial times 3 factorial. If I expand 7 factorial and I start going 7 times 6 times 5 times 4, I can stop at 3 factorial because it's going to be able to cancel with one of the 3 factorials on the bottom. That leaves me 7 times 6 times 5 times 4, and then 3 factorial is 3 times 2 times 1, and of course 1 times anything doesn't change it. If I multiply the top, I get 840. If I multiply the bottom, I get 6. And if I divide 840 divided by 6, I get 140, which is the solution.